Hi everyone, in this video we're gonna use what we've learned, how factorizing numbers, to what we call reduced fractions. Because if you know what fractions are, this is basically just dividing a whole number, an integer, by another integer which is not zero. But then you know that there can exist, or there exist, multiple representations of the same number. For example, 1 divided by 2 is the same as if you would divide 2 by 4, which, remember, is just saying how many times does 4 fit into 2, or if we divide 2 into 4 equal parts, how much is there in each part. And also remember that this really represents that number, 1 divided by 2. Of course, if you use decimal numbers, you're going to write this as 0.5, but don't need to use decimal numbers. This 0.5 really is exactly the same number as 1 divided by 2. But we can also write this as, 1000 divided by 2000, and so on and so on. So there exists multiple representations of the same number, so you might ask yourself, well, what is the best one? What is the best one? Well, and to answer this question, we're going to introduce some more terminology, another definition. So we need to calculate for this the greatest common divisor of the numerator and the denominator. There's a number here above the line and below the line. So which is the best one when the greatest common divisor of numerator and denominator equals to 1. So in symbol, if we actually look at a fraction a divided by b, where a is an integer, b is another integer, not 0, well, we can actually restrict ourselves to just positive numbers here. Doesn't really make a difference. It's just because I define divisors for natural numbers. You can also do it for integers. That's exactly the same. We can write this as the greatest common divisor of a and b when it is equal to 1. So the question is, how can we actually calculate this greatest common divisor? And of course, obviously, we're going to just use prime factorization. So use prime factorization. We're going to do this by an example. That's always the easiest way to actually get familiar with these new techniques. So let's look at the fraction 48 divided by 120. And the question is, try to write this number in its best representation. Another way is actually saying reduce this fraction. Reduce the fraction. You can keep on reducing as long as the greatest common divisor of the numerator and the denominator is not 1. We're going to see why. First, we're going to actually calculate this greatest common divisor. Well, what we need for that is we need to, first of all, factorize both the numerator and the denominator. And we can use that in the same technique as in the last video, but sometimes numbers are actually rather easy to do so, and we don't need that specific technique that works in general. Because 48, that's just 6 times 8, and 6 is 2 times 3, and 8 is 2 times 2 times 2, so we're done. The same goes for 120. 120 we can write it as 12 times 10. 12 is 2 times 2 times 3. 10 is 2 times 5. So we can now easily read off which prime numbers are both a factor of 48 and 120. Indeed, so there is a 2 here and there is a 2 here. So there is another 2 here and another 2 here, and there's a third 2 here that also is here. This fourth factor 2 does not appear in 120, so that stops. But we also see that we have a 3 here, which appears in both prime factorizations, and this 5 below does not appear in 48. So we can read off that the greatest common divisor of 48 and 120 is everything we encircled. So it's 2 times 2 times 2 times 3, which is 8 times 3, which is 24. And what we can do now is we can write 48 as 24 times the factors that we didn't encircle, that's only a 2 here, divided by 24 times the only factor that we didn't encircle for 120 is 5. And we can reduce this fraction now because 24 appears in the denominator and in the denominator and we're multiplying. So we can cancel this one out. Why is that? If you really want to remember it, we can write this as 24 divided by 24 times 2 out of 5. And 24 dividing into 24 equal parts, so every part is 1. So this is really just 1 times 25. 1 times 2 out of 5. And 2 out of 5, yeah, of course, what is the greatest common divisor of 2 and 5? Well, that equals 1, because they don't have prime factors in common, indeed. Only prime factors are 2 and 5, and they're different. So we're finished here. Using prime factorization, we wrote the fraction, we reduced the fraction 48 out of 120 to 2 divided by 5. Well, another example for you guys, try to reduce the following fraction, 825 divided by 210. Pause the video. Well, I'm gonna make the calculations as well. So let's factorize 125. This is divisible by 5. Then we arrive at 165. 165, 500, 300, yes, which is again divisible by 5. So then we are at 33, which is 3 times 11. So I have 125 equals 3 times 5 times 5 times 11. 210 is easier. 210 is just 21 times 10, which is 3 times 7 times 2 times 5. So 210 is 2 times 3 times 5 times 7. So I have to encircle the common prime factors, which is 1, 3 and 1, 5. So I immediately have that the greatest common divisor of these numbers is just 15. And so I can write this as 15 times 5 times 11, which is 55, divided by 15 times 2 times 7, which is 14. So this equals to 55 divided by 14. Next video, we're gonna see another example where prime factorization often comes in very handy. Ciao.